Hello everyone, I'm Hossein. Welcome to episode 3 of the Grasshopper From Zero series. If you've watched the first 2 episodes, you already know that so far we've focused mostly on the fundamentals and the underlying structure. In episode 1, we explored the overall structure of Grasshopper, how the environment works, how the components connect, and how we should think when working with it. In episode 2, we looked at some essential tools, especially the transformation tools, along with a few basic features that helped clarify the relationship between Rhino and Grasshopper. But starting from this episode, things get more serious. Because we're stepping into the heart of Grasshopper: data. Almost everything we do in parametric modeling, directly or indirectly, is connected to data management. If we understand the concepts of data, list, and later tree correctly, we can think systematically, control our modeling process, and build even the most complex projects without trouble. So today, we're taking the most fundamental and important step, a step that will make your path through the rest of this series much smoother. Section 1, why data matters. Before anything else, let's imagine a very simple situation. Suppose you need to create 50 columns in a project, or you need to generate 200 points for a pattern, or maybe you want to control a series of curves. If you try to build all of this manually, one by one, it takes a lot of time, and even the smallest change can break everything. For example, if the column heights change, or if the number of points increases, you'd have to rebuild everything from scratch. This is exactly where Grasshopper shows its true power. Grasshopper is designed to handle these repetitive and time-consuming tasks for you. It's almost as if Grasshopper tells you, just tell me the pattern, how many columns you need, what their spacing is, or what the general shape of the pattern looks like. I'll take care of the rest. But for Grasshopper to understand how these patterns should be created, we need to understand one very important topic: how to work with data. What do we mean by data? Very simply, it's the information we give to Grasshopper, like a number, a point, a line, or even a collection of these. If we understand how data is created and organized, we can generate as many objects as we need, change the model very quickly, and control everything at any moment without breaking the project. So learning data and list is the first real step toward understanding parametric modeling. From this point on, the world of Grasshopper will feel much more logical. Section 2, what is data? In Grasshopper, there is a very important concept called data. Data is simply the information that Grasshopper works with. This information can be many different things: a simple number, a point, a vector, a line, or a curve, a surface. So anything you bring into Grasshopper is considered a type of data. But here's a very important point. Grasshopper doesn't just work with the data itself, it works with the structure of that data. What does that mean? It means data is never alone. It always lives inside a structure. And the simplest, most basic structure is a list. For example, if we have 10 numbers, that's a list. 10 points, still a list. 10 lines or curves, again, a list. So it doesn't matter what the data type is: numbers, points, curves, or surfaces. What really determines how Grasshopper behaves is the structure of the data, not its type. Once we understand this, the behavior of many components becomes fully predictable, and from this point forward, the lessons start to make a lot more sense. Section 3, what is a list? Now that we understand data always lives inside a structure, it's time to get familiar with the list. A list is very simple. You can think of it like a queue. Everything inside a list has a specific position. We call this position the index. In Grasshopper, the index starts at 0. So the first item is 0, the second item is 1, and it continues from there. This might sound simple, but in reality, a huge part of modeling in Grasshopper depends on this exact concept. By understanding lists and indices, we can precisely control our data and place everything exactly where it needs to be. Section 4, building lists. In Grasshopper, lists are at the heart of working with data. Now, we're going to walk through a few important tools for creating lists using simple examples. Construct domain is a tool we need to understand before working with series and range. A domain is simply a numeric interval between two values. Many list generation tools like range or random won't work without a domain because they need to know exactly between which limits the numbers should be created. Here we have two simple inputs, A, which is the start value, and B, which is the end value. The output is a complete domain between these two numbers. For example, if A is 0 and B is 10, the output becomes the domain. Where do we use a domain? For tasks like dividing a span into equal segments, for example, when creating a grid or generating guidelines. One important note, a domain can contain integers or decimal values, which makes it very flexible. The series component is a simple and organized number generator, like a little machine that prints numbers step by step in sequence. It works by starting from an initial value, adding a fixed amount each time, and repeating this process a specific number of times to produce a complete list of numbers. To do this, we have three inputs: the number we start from, start, the amount added each time, step, and the total number of repetitions, count. For example, if we start at 1, add 3 every time, and repeat this process 5 times, the output will be an ordered list like 1, 4, 7, 10, 13. Series has many uses. We can use it to control stair heights or the spacing of architectural elements, to generate precise values for parametric inputs, or even to build a simple numerical pattern that we later modify with formulas or transformations. It's one of the most fundamental, and at the same time, one of the most practical ways to build numeric lists in Grasshopper. Range. You can think of the range component as a digital ruler. What it does is take a numeric interval and divide it into equal segments. Then it gives us the points at each division. Because of that, understanding its inputs is very important. The first input is the domain, the interval we want to divide, like the range from 0 to 10. The second input is steps, the number of segments we want to divide the domain into. And here's the key detail. Steps refers to the number of divisions, not the number of output points. Range always includes both ends of the domain. So if we divide the domain into 4 segments, we get 5 points. If we divide it into 5 segments, we get 6 points. For example, if we use the domain from 0 to 10 and ask for 4 segments, the output will be 5 evenly spaced values: 0, 2.5, 5, 7.5, and 10. It's just like placing a ruler on the interval and reading all the tick marks. Range is most useful when we need perfectly equal spacing. For example, when designing grids, laying out columns, or generating input values for parametric forms. Its main difference from series is that series advances with a fixed step size, while range works by dividing a domain into equal portions. The random component generates a list of random numbers, values with no specific pattern, but all contained within a defined range. It has 3 main inputs. First, n, which is the number of values we want to generate. Second, seed, which controls the randomness and determines whether the output changes each time or stays the same. And third, domain, which defines the numeric interval, for example, from 0 to 10. The result is usually a scattered, irregular list of values within that range. We use random in many situations, especially when we want design features to feel a bit unpredictable. For example, to set tree heights, pipe diameters, lamp spacing, or anything that needs a natural or irregular character. You can also combine it with other components to randomly select or remove elements in a model. Overall, random is one of the tools that brings a sense of variety and dynamism to parametric design. The random reduce component takes a list and randomly removes or keeps a portion of its items. All we need to do is provide the main list and then specify how many items should be removed or kept. There is also a seed input that controls the random behavior and lets us repeat the same random selection whenever we need to. For example, if we start with a simple list from 1 to 5 and ask the component to keep only a few items, the output, depending on the seed, might look like 1, 4, 5. These are 3 values randomly chosen from the original list of 5. Random reduce is especially useful when we want to select only a few elements from a large set, for example, when placing objects randomly on a site or choosing a handful of points from a much bigger collection. When combined with components like random or cull pattern, it allows us to create random yet still controlled patterns. And if we ever need to turn those random values into whole numbers, we can easily use components like round or integer afterwards. The Fibonacci component in Grasshopper generates a Fibonacci sequencer list, where each number is the sum of the 2 numbers before it. This sequence usually starts with 2 initial values and then continues from there. The component has 3 inputs. First, seed A, which defines the starting number of the sequence. Second, seed B, which defines the second number and becomes the basis for generating all following numbers. Third, number, which tells Grasshopper how many values we want to produce. For example, if seed A is 0, seed B is 1, and number is 10, the component will generate 10 values starting with 0 and 1, 0, 1, 1, 2, 3, 5, 8, and so on. The output is a list of Fibonacci numbers that we can use to control proportions, spacing, or parametric dimensions in a model. This tool is especially useful when creating organic designs or natural patterns, and by adjusting seed A and seed B, we can generate custom versions of the sequence. If you're enjoying this kind of content, please like this video, leave a comment, and subscribe to the channel. Don't forget to hit the notification bell so you don't miss any future tutorials. And if you know someone who would enjoy this, share this video with them too. Section 5. Basic list management. Now that we have created a list, the next step is to control and manipulate that list. Grasshopper provides a variety of basic tools for this purpose. Let's go through the most important ones. The list item component allows us to select a specific item from a list. The logic is very simple. You input your main list and then specify the index of the item you want. An important point, indexing starts at 0. So the first item is 0, the second item is 1, and so on. For example, if our list is 10, 20, 30, 40, and we set the index to 2, the output of the component will be 30, which is the third item in the list. List item is widely used in parametric design when we want to isolate or modify a specific value, or when we want to combine the list with other tools like shift list or reverse to create more complex patterns. This component is one of the most fundamental tools for working with lists in Grasshopper, and we almost always need it in any parametric modeling. The list length component is used to determine the number of items in a list. All you need to do is input your main list, and the component outputs a single number representing the length of the list. For example, if our list is 5, 10, 15, the output will be 3, which means there are 3 items in the list. List length has many uses when we want to create loops or cycles, or when we want to use this length as an input for tools like series or repeat data to control the number of repetitions or the size of new lists. This component is one of the fundamental tools for list management in Grasshopper and is useful in almost any parametric project. The reverse component is used to reverse a list, which means it rearranges the items from last to first. All you need to do is input your main list, and the output will be the same list, but in reverse order. For example, if our list is 1, 2, 3, 4, the output will be 4, 3, 2, 1. Reverse is widely used in parametric design when we want to create symmetrical patterns or specific combinations of lists. This tool is very useful. It can also be combined with series or range to design parametric forms with custom orders. Reverse is a simple yet powerful tool for managing and controlling lists in Grasshopper. The repeat data component allows us to repeat a list or a specific value multiple times to create a new list. The first input is data, which can be a list or a single value. The second input is length, which defines the total number of items in the output. This means Grasshopper will repeatedly generate the data until the desired length is reached. For example, if data is 1, 2, and length is 6, the output list will be 1, 2, 1, 2, 1, 2. In other words, the same data is repeated continuously until the specified length is achieved. Repeat data is very useful in parametric design. When we want to create long lists with repeating patterns or generate repeated grids and geometries, this tool is extremely helpful. With repeat data, we can easily produce regular and predictable patterns in our model, making data management simpler. The shift list component is used to move the items in a list forward or backward. The first input is list, which is our main list. The second input is shift, which defines how many positions the items should move. If the value is positive, the items move forward. If it's negative, they move backward. The third input is wrap, which controls whether items that move out of one end should reappear at the other end. For example, if our list is 10, 20, 30, 40, and we set shift to 1, the output will be 40, 10, 20, 30. This means the last item moves to the beginning, and the rest of the items shift by one position. Shift list is widely used in parametric design when we want to create repeating patterns with phase shifts, or combine lists with components like merge and entwine to generate multi-layered data. Shift list is one of the fundamental tools for controlling the order and patterns of lists in Grasshopper. The merge component is used to combine multiple lists into a single list. Its operation is simple. It places the lists one after another to produce a combined list. The input of this component can be several lists that we want to merge together. The output is a single list containing all items from the input lists in order. For example, if we have two lists, 1, 2, and AB, and we feed them into merge, the output will be the combined list 1, 2, AB. Merge is useful in parametric design when we want to easily combine multiple datasets into a single list for further processing. This tool is fundamental and very useful for managing and merging data in Grasshopper. Section 6. Selecting, removing, and sorting. This section allows you to have precise control over your data and lists. The key tools include cull pattern, cull index, sort list, and replace items. The cull pattern component is used to remove or keep items in a list based on a pattern. It tells Grasshopper which items to keep and which to remove. The pattern consists of Boolean values, true and false. True means the item is kept, and false means the item is removed. There are two inputs. First, list, which is the main list we want to modify. Second, pattern, a list of Boolean values specifying the status of each item. The length of the pattern usually should match the number of items in the list. If the pattern is shorter, Grasshopper repeats it in a loop to cover the full length of the list. For example, if our list is 10, 20, 30, 40, 50, and the pattern is true, false, true, false, true, the output list will be 10, 30, 50, meaning only the items with true remain. Cull pattern has many applications. We can remove even or odd items, or create more complex patterns to keep only specific elements. When combined with other tools, This component allows precise control and enables advanced parametric patterns. The cull index component is used to remove specific items from a list. It tells Grasshopper which indices should be removed. There are three inputs. First, list, which is our main list. Second, index, which can be a single number or a list of numbers specifying which items to remove. Third, wrap, which controls whether indices that are out of the list's range should wrap around and start counting from the beginning. For example, if our list is 10, 20, 30, 40, and we set index to 2, the output list will be 10, 20, 40, meaning the third item in the list is removed. Cull index is useful when we want to remove one or more specific items or prepare data for further processing. This component is a fundamental and practical tool for precise control of list elements in parametric design. The sort list component is used to sort the items in a list. This tool can sort the list in ascending or descending order. In addition to the sorted list, it also provides an index output, which shows the original position of each item before sorting. The inputs include key, the list of keys to sort by, and values, the list of data that will be reordered according to the key list. For example, if our key list is 30, 10, 40, 20, the output sorted list will be 10, 20, 30, 40, and the index output shows the original position of each number. Sort list is very useful in parametric design when we want to sort data before using it in geometry or control the order of parametric elements. This component is a fundamental and practical tool for managing and organizing lists in Grasshopper. Replace items. The replace items component is used to replace specific values in a list. In other words, it tells Grasshopper which items to change and what new values to assign. The inputs include first, list, which is our main list. Second, item, the new value that will replace the old one. Third, indices, which specifies which items should be replaced. Fourth, wrap, which controls whether indices that are out of range should wrap around and start counting from the beginning. For example, if our list is 1, 2, 3, 4, and we want to replace the item at index 1 with 10, the output list will be 1, 10, 3, 4. Replace items is useful when we want to change specific values without creating a new list, or update data to precisely control geometry and parametric patterns. This component allows us to manage lists and modify specific items easily and efficiently. Section 7, Practical Example. In this section, we will create a small parametric project from start to finish, combining all the tools we introduced earlier. The goal is to generate points along the x-axis, remove some of them, and finally create polygons with parametric heights. The first step is to define the range of positions for the columns along the x-axis. We use the construct domain tool for this. Inputs, A vote 0, B vote 10, output, domain 0, 10. This domain will later be connected to the range tool to produce equally spaced points. This is a fundamental step because without it, we won't have a precise list of positions. Next, we generate points along the defined domain. Range tool, domain input, output of construct domain steps, 5, meaning we want 5 points output, 0, 2.5, 5, 7.5, 10, y-axis. We can keep the y value constant, for example, input 0 in a panel, and connect it to the y input of construct point. This sets the x positions of the columns, ready to create 3 D points. Using the construct point tool, we create the initial 3 D points, x input, output of range, i.e. x positions, y input, constant value, for example, 0, z input, 0, initial height, that can later be replaced with actual heights, output, 0.3D. Now the points along the x-axis are created, ready to connect heights and form the next geometric elements. Remove some items with cull pattern Using the cull pattern tool, we can remove some points to create different patterns. The pattern consists of true and false. True means keep the item. False means remove it. This allows us to select specific points for the next geometry. Draw polygons with radius from series next. We create a polygon for each point. The number of polygon sides can be determined using random or series to add variation. The polygon radius can also be generated by a series, so the values are parametric. Finally, to give volume and actual heights to the polygons, we use range input, height domain output, a list of heights for each polygon. These heights are added to the z coordinates of the points to create 3D volume and final geometry. With these 6 simple steps, we have created a complete parametric project. Initial points were generated, some were removed, polygons were created with variable radius and number of sides, heights were applied. This example is a practical summary of how to combine Grasshopper tools for parametric design. It demonstrates how fundamental tools like domain, range, series, cull pattern, and construct point can be used to create complex and flexible geometry. Before we finish, one quick note: everything we learned today is just the beginning. In the next episode, we'll dive into a key concept in Grasshopper, the data tree. Don't miss episode 4. Today, we learned together how important data and list are in Grasshopper and how they can form the backbone of parametric modeling. We saw how we can create lists and manage positions and heights, remove, replace, or sort items, and control our parametric model by connecting tools correctly. Learning these fundamental concepts paves the way for more complex designs and real-world projects. If you found this video helpful, don't forget to like and comment, because it helps me create better and more practical tutorials. And if you know someone who loves parametric design, make sure to share this video with them so you can learn together. Thank you for staying with me until the end. I'm Hossein, and I hope you always stay inspired, curious, and creative. Stay tuned for the next episodes, where we will dive deeper into Grasshopper's data and tools and create exciting parametric projects together.